Okay, in this video I'm going to do problem number 2 here on this page, and it asks a series of questions, and if the answer is yes, these are yes or no questions, and if the answer is yes, we're supposed to give an example, and if the answer is no, explain why not. Okay, and so the question is, first, part A, is it possible for a function to be one-to-one when the size of the domain, that is the size of the set A, is larger than the size of the range, that is the size of the set B? Is it possible to be one-to-one? Well, one-to-one is defined by saying that if let's see here. How am I going to write it here? Let X be an element of the domain and Y be an element of the domain. Then we have that if f of x equals f of y, that implies that x must have equaled y in the first place. Okay, that's what one-to-one means. And what that means is that we don't ever have, from the domain to the range, let me call them A and B because that's what we have here, we don't ever have more than one element. We never have this situation where two elements of the domain are mapped to the same element of the range. Okay? And so here's the case where f of x does equal f of y and where x did not equal y. And so this is a case of not one-to-one. Okay? And so this is an illustration of when the function is not one-to-one. And so what we're looking for is whether or not it's possible, if A is larger than B, the size of the set A is larger than the set B, is it possible for it to be one-to-one? And the answer is no. And it's due to the pigeonhole principle. Meaning that if you have n cubby holes and you want to put n plus 1 things into those n cubby holes, then one of those cubby holes is going to contain at least two elements. Okay? And here we're going to map the elements from A to B, and we don't want to have any two of them mapping to the same one. However, because there are more elements in A than there are in B, even if you map all of the elements in A to different elements in B, when you get to that last one in A, you're always going to have to map to an element in B which has already been mapped to. Okay, so a simple example would be 3 elements in A and only 2 elements in B. You do your best to keep it one-to-one and don't map any 2 elements to the same one, but you always end up with this last one that has to be mapped to one of the same ones. So it can't be one-to-one. Okay? For part B, is it possible for the function to be one-to-one when A is less than B? Sure. Just don't map any 2 elements to the same one. A simple example would be A having 2 elements in it and B having 3. Just map those 2 elements over so they don't map to the same element, basically. Okay? Okay. And I could say that I'm supposed to give an example now. So I could say that F maps the set A, B, C to the set Y, Z. Here the domain is smaller. Oops. I'm supposed to make my domain smaller than the range. Y, Z, W, X. There, the domain is smaller than the range, and f of A is y, f of B is z, Sorry about that small writing. And f of c is w. Okay, so this is 1-to-1 because I don't have any repeats in this column here. Okay. Can it be 1-to-1 when the size of A equals B? Absolutely. Yes, and an example would be f that maps A, B, C to itself. This is probably one from the previous problem. And f of A is equal to B, f of B is equal to C, and f of C is equal to A. It's 1-to-1. And it happens to be onto also, but here with we're mapping, f maps the set ABC onto itself, and so the domain and the range definitely have the same size, and here's an example of a 1-to-1 mapping. Now we're going to ask the same 3 questions about onto. Okay, can it be onto when the domain is larger than the range? Onto means that that for all x in the range, there exists a y in the domain such that f of y is equal to x. In other words, every element in the range has a pre-image. X is an element in the range and y is its pre-image. Okay, so here's the domain, here's the range, here's x. Oh, that's y. And y maps to x. X is the image of y. X is the image of y. Y is the pre-image of x. And so we're saying here that every element of the range has a pre-image. Okay, I'm reviewing these definitions as I go. Sorry, I'm not just coming out and solving the problem. So here, the question is, if the domain is bigger than the range, can it be onto? Oops. The size of the domain is bigger than the size of the range. Absolutely, it can be onto. And I think I could just use, no, I need to make a new example. Let's let f map the set A, B, C to the set x, y. Now the domain is larger than the range, and f of A is equal to x, and f of B is equal to y. And so every element in the range has a pre-image. Okay. E. What if the size of the domain is less than the size of the range? Well, then you're not going to be able to go onto. And essentially it's the pigeonhole principle again. There's not enough elements in the domain to map to every element in the range. Okay, and we can kind of draw a little picture of that here. We can say, okay, suppose that we're mapping from the domain to the range here, and there are 2 elements in the domain and there are 3 in the range. Well, we're going to map these guys over like that, and then this guy has no pre-image. Okay. Finally, f, if the size of the domain and the range are the same, then yes, we can, and the same example as for part C, I believe. Yeah, here we have the size of the domain and the range being the same. You map them across, and this is 1-to-1 and onto. Every single element of the range has a pre-image. A, B, and C all have pre-images. So it's the same example as N part C. Every element has a preimage. Every element of the domain of the range Okay, sorry about my handwriting on this one. Okay, hope that helps. Hope it wasn't too long-winded.